Welcome to Lesson 1 on the development of the periodic table. Our lesson objectives explain how the periodic table was developed and organized and identify similarities and differences between periods and groups. The periodic table was first organized by Mendeleev, and he organized these original elements based upon the atomic mass, and it was increasing from left to right, as you can see here, 7, 9.4, 11, 12, etc. And he also noticed that these vertical groups had similarities between the elements, although they did note there were a few inconsistencies. And these inconsistencies were later fixed when the table was reorganized by Moseley. This is the modern day table, which is in your periodic table, and he organized them based upon the number of protons, which he called the atomic number. And that fixed most of the inconsistencies with the exception of hydrogen, which we talked about in class. And this sets up what is called periodic law, which means that there are similar properties that reoccur periodically when elements are arranged according to their increasing atomic number. Much like if you look at a calendar, there is a periodic repetition going across. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, repeat. And that the vertical groups have similarities. In this case, it happens to be the same day of the week. So the result is that we can fill in gaps to predict undiscovered elements and their properties. So at the time of this periodic table, when it was taken, this element was not discovered, but we could predict a lot about it. So it's going to have properties similar to Mn. In terms of atomic mass, if I look at the mass of MO and the mass of Ru, the mass of MO is approximately 96, and the mass of Ru is approximately 101, so it's somewhere in between those masses. And then MO has an atomic number of 42, and Ru has an atomic number of 44, so therefore the atomic number, the number of protons, would be 43. So let's check your understanding. Can you explain how the periodic table was developed and organized? So looking at the table, there are two main themes. There is the horizontal rows, which are the periods, and these are equal to the number of energy levels or shells that an atom has. So period 2 would have 2 shells, and period 3 would have 3. And then there are vertical columns called groups, and elements in a group have the same number of valence electrons, which results in similar properties. So here is your periodic table, and you can see it's labeled periods and groups. So periods are going horizontal, period 1, period 2, period 3, etc. And you can see that the period number 2 here means there's 2 energy levels or shells. Period 3 has 3 in the configuration, period 4 has 4, and so on and so forth. And then the vertical groups, here's group 1, 2, 3 through 12, and then 13 through 18. And we can see then in the groups that they have the same valence electron number, with the exception of this central part here. If we go back, groups 3 through 12 have a variable valence number. If you look here, 2, 1, 2, 2, 2, 1. And so there are some inconsistencies in that section, but the rest of the table, the group number is going to indicate how many valence electrons we have. So group 1 has 1 valence, group 2 has 2 valence, 3 through 12, as I said, is a variable valence, and then groups 13 through 18, 13 has 3, 14 has 4, 15 has 5, 6, 7, and group 18 has 8 valence electrons. And again, that's why they react very similar and have similar properties due to that valence electron number. So as I said, the reactivity of the elements are determined by the number of valence electrons. And all atoms except hydrogen are stable when they have 8 valence electrons in that outer shell, that valence shell. We call that a full valence shell or a stable oct, meaning 8, octet. So the closer to a stable octet, to a full valence shell, the more reactive an element is. It is important to note that period 1 elements need only 2 electrons to be stable, not 8, to have a full valence shell, and that consists of hydrogen and helium. Notice there's only one number in the configuration, and it is 2. Helium is stable, it is unreactive, and it only has a full shell of 2. We call that a stable duet. So let's look at an example. Which 2 elements have similar chemical properties and why? So from the list here, NaKLiBe. So here's NaK, here's Li, and here is Be. Out of that list, which two have similar properties? And the answer is going to be Na and K because they're in the same group and they have the same number of valence electrons, which happens to be 1. So they're going to have similar properties and similar reactivity. Let's check your understanding. Can you identify similarities and differences between periods and groups? At this point, you should be able to explain how the periodic table was developed and organized and identify the similarities and differences between periods and groups.